This is a 1788 Matthew Boulton and James Watt rotative steam engine. I'm Darren, and this is the Industrial Revolution. This engine was built by James Watt, used by his business partner, Matthew Boulton, at Boulton's Soho Manufactory in Birmingham, England. This is actually a 1932 replica built here in the museum, at Henry Ford Museum in Dearborn, Michigan. The original is in a science museum in London, England. The original, and consequently this replica, is the oldest unaltered rotative engine in the world. It used to be called the lap engine, and the reason it was called the lap engine is because of what Boulton used it for. In his factory, this engine was used to drive 43 lapping machines. Those are metal polishing machines, and he ran this engine in his factory for 70 years. There's a lot of innovations here. Let's take a look at what those innovations are. Probably expecting I'm going to start here, but actually let's start up at the very top. If we come up here to the top, if you remember from previous Newcomen and Watt engines, the end of the beam had a big curve over the top of it connected to the piston. It's because the piston only goes straight up and down and the beam changes directions. Well, that rigid metal link is called the parallel motion link, and that was an innovation on this machine. Let's take a look at the other end while we're here. So we come down the beam. Remember earlier Watt and Newcomen engines all had a chain coming straight down, and that ran to the pump shaft. Here we have a rigid shaft. Now the rigid shaft goes to this gearing system on here. This odd gearing system is called a sun and planet gear. According to some accounts, it was actually done in order to avoid Watt having to pay patent licensing fees. But one unique feature of it is that each time that the piston either goes up or down, because of the way it's geared, it actually causes the main wheel to do a full revolution instead of only a half a revolution as is common. And speaking of the wheel, let's take a look at that. Most steam engines you've seen have a big, heavy, massive steel flywheel. This one doesn't. Not only does it not have a big, heavy, massive steel flywheel, it doesn't even have a steel flywheel. Look closely. This has wooden toothed gears on it. That was used to drive machinery, and if you think about it, if you go back to water-powered or wind-powered sawmills or grist mills, they were used to running these. So as we look at this, the plug tree looks very similar, and we have a single large cylinder. However, if you know the Watt steam engines, his innovation was that he added a second cooling cylinder. If you look to the right, you see what looks to be two cylinders in the gray steel. And the one nearest us, the higher one, is the steam inlet cylinder. The further one is the cooled condensing cylinder. The silver pipe was added by Henry Ford when it was moved here, and possibly, I don't know if this ran steam or if it ran compressed air. Other engines in the museum were set up to run compressed air. If you look at the cylinder up at the top, you see there's a steam connection and a vent connection. And at the bottom, you also have the steam and vent connection. So what's going on? Well, that's another one of these innovations. This is one of the first double-acting cylinders. It pushed steam into both ends and condensed it out of both ends as well. This still ran low-pressure steam, only about 5 psi. Watt believed that high-pressure steam was dangerous, so he didn't use it. and criticized those who did use it. Low pressure steam basically would not blow up on you. It wouldn't cause any serious injuries. It was easy to manage, it was easy to generate. But over here we have the part that's actually doing the work. So this is turning this large wheel to power machinery. And here's another innovation. We have this governor or regulator. Where these two large steel balls, they would adjust how far you opened and closed the steam valve with each cycle of the piston. Now, unlike a lot of other systems that you've seen, the controls here are managed not by metal rods and linkages, as you see on later steam engines, but by this chain that's running across pulleys. And that works perfectly fine. So this is not an absolutely smooth motion. That would have come later, and that would have come through the addition of the large, heavy steel flywheel, of course. So this engine introduced a lot of innovation and really led to the way that all subsequent rotative steam engines worked as opposed to pumping steam engines. And that's why this is the Industrial Revolution. Hey, before you go, I do need your help to keep this channel going and also to help keep it growing. The easiest thing you can do to help is just to click the like button. Also, if you can do subscribe and notify, then you'll know when I release new videos and you'll be able to watch those. Also, I have a Patreon page over at patreon.com/industrialrevolution. And if you have any questions, comments, places you think I should go visit, please leave those down in the comments section of the video. That's actually the best way to tell YouTube, hey, this is a channel worth watching. Thanks for watching, and I look forward to seeing you at the next one.